experience.
Okay, yeah, continue.
That, if we make like a buddies or 2 or 3 person in a group, and group is responsible for doing any homework or any presence or absence, then it has worked.
You can try to do it, and like I recommend like whatever kind of experiment you guys want for your own self-learning experience, you all can try that. Like, yes, Kishan, I'm able to see your message. How many does agree with the Vishnu's recommendation? Let's have a quick voting for that. Okay, I can see Aman, Kishan, Gaurav are agreeing. What about the remaining people? Okay, Sai, Bhuvnesh, I got 5 votes. I have 9 people in the class. Guys, be quick. Okay, Mani, Vipin, and Ashish. If you guys don't agree, then I'll simply make the groups of the people who have agreed. Okay, Vishnu, I know you do agree. So, yeah, fine. So I can divide the group as okay, like do you have your own preferences or should I divide you into groups? Yes, guys, you can divide, you can divide. Okay, okay. Anyone who will be like, no, I have my preference. You can suggest your ideas as well. This whiteboard. Okay, okay, you can divide, no preference. Will be fine based on your observation till now, active and not active. Okay, so Kishan and Aman and Sai, you three can be in one group. Bhuvnesh, Gaurav, and Vishnu, you three can be in the next group. Since the other people are not responding, but in case you guys want to pair up, then Vipin, Ashish, and Mani, you three can pair up. Or if you want, I can merge you in these two, like these 2 or 3 groups. So that will be fine. Okay. Anyone who is not fine with the divisions, they can say. And if you're fine, then it's fine. Yeah, in this team building activities, what you are actually gonna do. That is one thing you need to tell me now. Yeah, you can start. You can take like my suggestion will be if you're not able to solve some questions anytime, then you can just tell me. I'll start this meeting. I'll break you into the breakout rooms. Like I will divide you into the breakout rooms. You all can discuss and solve. Homework you can represent, attendance. Yeah, I guess the people I've divided are actually active, so I need not bother about it. Okay. Homeworks you can do for sure. That will be a great thing. And Kishan, I went through your code yesterday. So there was just one problem that I figured out. And further then I was not able to I was not having the time to see it. Okay. So the problem which I've just give me a minute. Let me. Yes. So if you are having the matrix as 1, 2, 3, 4, 5, 6, and 7, 8, 9. Okay. You figured out the sum of this particular diagonal and you have stored it a in dia variable, right? But there is not just one diagonal. Okay. You can have this diagonal as well, right? So you need to figure out this diagonal also. There are two main diagonals in any matrix. Okay. You can't just figure out one. Clear? That's what one problem I figured out. And yeah, I guess you can look into this once and see if the problem is getting resolved. Otherwise, further, I'll see it today only and we'll get back to you. I hope it's clear. Okay. Okay, so let's move on. And
I have one question in the earlier problem which you have gave yesterday.
yeah,
Uh,
in
there,
Queen's problem.
no, before that,
Okay.
index printing one.
Yep.
So the question is like, open and ask.
Yeah, I'm opening that. What's your doubt? You can tell me directly.
Uh, like yesterday we were supposed to print permutations of all the values with spaces, right?
Correct.
So we have written those permutations where after 0 we are taking only 2 spaces. So my question was, we can increase the spaces after 0 as well.
Yeah, see what I was doing now. Just a minute. Let me stop sharing. Let it take its time. The problem was like I was putting here 0, 0, then blank spaces, then 1, 1, 1. Like I didn't exactly remember the.
I1 and 3 2.
Okay. Let it be 3, 1 as of
Yeah,
now.
not an issue.
And I'll just keep 4 2s here and yeah, the remaining blank spaces. So initially what my agenda was, one by one, I was increasing the spaces in this particular area, right? Like initially I wrote 0, 0, 2 spaces, triple 1, and then 1, 2, 3, 4. Then I moved the 2. And then on the the spaces after 2 is reduced. Again, for the next permutation, this was kept constant. And then again, in between spaces increased. Then again 2, 2, and then this. So once you have reached the extreme limit, that means you have reached here. That means the spaces in between has also reached the extreme limit. That means in between these, all the spaces are covered. And at the end, you are writing 4 times 2. Now, what is the other probability you have left with you? Now, the other probabilities, you have to shift the spaces in between 0, 0, and 1, 1. So it will look like this.
Fine. This is what
Now
I
you,
was
yeah, now you will start reducing the space from here and it will start adding on to here. That was the agenda of this question. Clear?
Yep.
Okay. So I hope I have shared the link of recursion whiteboard, like the whiteboard recursion link.
I think no.
No? Okay, I will share it.
Yeah, I have it open. I can put it.
You have it open. I didn't get it.
Yeah, the recursion whiteboard link.
Yep.
I know you had posted it. I can repost it.
Yeah, sure. You can ping it in the group. Okay, then let's quickly start on with the recursion. At least have some base today so that we can have, like, we will be good to go tomorrow. How many of you know about linked list? What is it? Yes, how many of you know about linked list? What do you understand by the term linked list? And yeah, for what purpose it is used? Such kind of questions you can answer to me. Anyone who knows about linked list?
Yeah, it's a bunch of nodes in and which are connected to each other by next pointer.
Continue.
Um, so in order to get to any point, we start from the first and then traverse using next until we get to that point.
Okay.
And it can be two ways, like forward way or as well as backward, so that we have a doubly linked list.
Okay, searching is fast. Data structure having the nodes connected by the links. Add and delete is fast. Okay. Store data in the form of nodes which are connected to each other for storing, searching, inserting. It's basically like you don't have to like define the size of your data type in advance. As soon as you want, like let's suppose I just have one node over here, 5. I want to attach another node or I want to insert another data. We will quickly create another node and I will attach some other data. So it's like we need not define any type of size for the linked list. That is one of the advantage. Next is someone is saying like it is exactly like it performs all the function which an array can perform. You can search in this, you can sort your linked list, you can insert the numbers in the middle, like all the kinds of operations which an array can perform. All those kind of operations can be performed on the linked list. Okay, just an advantage to the linked list, and the concept behind the creation of the linked list data structure is that whenever array was getting created, there was always some buffer space which was getting wasted. Okay, even in the array list concept, you also know that though it is a dynamic list, at some point there is some time when the buffer space is being left, right? In an attempt to increase the size of an array list, sometimes the buffer space is left. But in terms of linked list, if you see the same thing, there is never a buffer space left. Hence, it is very useful in terms of, you'll say, in saving space. Okay, so it is a space efficient. Clear? Next, another advantage of linked list is in an array list, you always need a continuous memory location in your memory, and it should not be like that you have kept one of your data in this memory location, your other memory location is here, and you have stored your data here. Array don't store the data in this way. It should be always continuous. Okay. But if you talk about linked list doesn't even bother about where its next data is, because what it stores the data in its one of the, like you can say, the division, and then in the next division it stores the address of your next node. So it doesn't bother about whether the numbers are stored in a continuous manner or not. It is still able to fetch that number. Clear? Yes. So these are a few of the you can say the characteristics of the linked list for which it is generally preferred. Okay, let it be as it is. Now we will move on. Anyone having any confusions in the definition and characteristics of a linked list? Okay, great. So now, does anyone know about the classification of the linked list, like how many type of linked list we have? Three type of linked list. Okay. If we talk about the type of linked list, we have singly linked list. Just give me a minute. So one is singly linked list. To understand this, the name itself suggests single. That means you have one node which is attached to the next node. That node is attached to the next node. It's basically like a single line flowing. Okay, there is no disruption in between. Next is doubly linked list. So this concept arised when it was like we have a very good path to travel from like the first node to the ending node or to any intermediate node, but we don't have any way back, right? Because if you all know, we can only traverse in the linked list via the links, and if we don't have the link backward, how can you traverse in the backward direction, right? And from there the concept of doubly linked list came. Doubly linked list is nothing but you have your like starting node pointing to the next node as well as your next node pointing to the starting node, and this is with every other node. It's basically this linked list is bidirectional. You can travel any way you want. Clear? Next is circular linked list. Circular linked list can be of both the types. It can be of singly linked list type. It can be of doubly linked list type. So singly linked list, like you have attached one node to the other node, and at your ending node, instead of pointing it to null, you are pointing your last node to the starting node. In terms of doubly linked list, like doubly circular linked list, your last node will be pointing to the first node, and your first node will be pointing to the last node. This is how this linked list is designed. Clear? Okay. Now, since we are only like seeing here linked list and we are seeing here nodes, so we should also be familiar with the structure of the node. Yes, we should know what this node is, right? Okay. So what should a node contain? What is the essential things that a structure of node should have? It should be storing some data and it should be having the address of the next node. Okay. So I'll write here class node. So it will be having int data and the next the address which will be pointing to your next node. So defining the node structure, this data will be given by the user. So clear? You can also initialize your next here to okay then. So I have told you all the types. I have told you all the I have told you the structure of the node. Few terminologies left. The first node of a linked list is always named as head node, and the ending node is termed as tail node. Clear? Let me write the name for these as well. This is your singly circular linked list. And this is our doubly circular linked list. Your very first question for this particular linked list exercise will be, you need to create a singly linked list containing 1 to n elements. That is, you have to create singly linked list. Okay. And it should be having n nodes. Okay. And the value of node, or you can say the data inside the node, should be as per its position. That is, if it is your first node, then one number should be in it. If it is your second node, then second number, third node, third number, and similarly up to n nodes, last node will be n value. Clear? Okay, so can you do it? Okay, you can try. So I'll give you 2 to 3 minutes of time. Try to do it. Yep, I'll share it. I told you na, that you have to take the numbers from 1 till n. If numbers will be given as input, then obviously I would not have told you it will be sequential, right? Sorry, my bad. Okay, did anyone figured out the solution for this? Trying. Okay, you want some more time? Okay, so you need not create linked list when you know you can attach the nodes. I'll just write the sample. I'll write here node singly linked list. And here I'll be having int n, the number of nodes I need to create. Not able to add node predefined linked list class allows directly to correct. That's right. So here inside this, you create your head node first of all. Node h equals to new node of 1. Now you know you need to like add n nodes, and for all the procedure is same. Hence, iterate on them for int I equals to start from 2, I less than equals to n, I plus plus. Every time you are creating the new node, so here you will be creating let's suppose n I have written new node of I. Now you need to point this head to this new node, right? So your head dot next will be equals to n. Are you getting this? So take this as an example. This is your head. This is your new now. And its head dot next is pointing to new. Are you able to get this? Next time you want to attach this 2 to the 3, right? And for that, you should move your head from here to here. Are you all getting this? This time your head was at 1 and your new node was at 2. So I pointed h dot next equals to n. The next time your new is gonna be at here. So you should be having your head here, right? So that you can point it or create the link. So for that reason, you need to move your head equals to head dot next. Clear? And at the end, when you are done, you need to return the head node, right? That means the starting node of your singly linked list, so that through that you can traverse the entire linked list. Yes or no? But you have already moved your head node to the the different nodes. Now you don't have the track of your head node. For that reason, you should store your head node temporarily in your some th variable. So at the end, when you need to return it, just return th, and th has still stored the address of the first node. And that's it, you are done. Are you all clear? In the similar way, try to create the linked list. That means the linked list in the sense, try to create doubly linked list, try to create singly circular linked list, try to create doubly circular linked list. Got it? So I have given you just one example. You all know that what needs to be done. Okay. One thing that I want you all to remind you all, for the doubly linked list, this particular node not should only contain the next variable, it should also contain the previous variable, right? That means it should also know the address of its previous node, since it is a doubly linked list. So just don't forget for that as well. Okay. These are the two things I wanted to remind you. So can I expect from you all these three codes by tomorrow? Because these are quite simple and they will be good for your own practice, as you will get to know like how to write the code for the linked list and all. Clear? So I'll stop the class at this note today. You all try you all solve these questions, and from tomorrow we will discuss approximately 10 basic questions on the linked list. Very basic, not at all tough. Okay, so please don't make me write these codes tomorrow as well. I'm expecting the answers for this.
So we just have to create the objects, or do we also have to traverse left and right like that?
You can see here.
That's
You
it.
just need to create a doubly linked list or circular doubly linked list or whatever, like all these kind of variants. And at the end, you need to return the head node. That's it.
Okay.
Clear? Yeah. Yes. Which code is it about, Kishan? For finding string. Okay, I'll look into that. First, I'll look into your magic square thing and then we'll look into that. Okay, then. So, yeah. Thank you everyone for joining the session today. Do you all want me to conduct a lab session on weekends? Okay. This weekend. I have just got 2 responses. What do you find if you have time? 3 responses. What about remaining people? 4. What about the remaining people? Just 4 responses. How can I conclude with that? Okay, yes. But I will be able to take it only in the morning. Like you can say around 9 or 10. It won't be possible for me in the evening. Good for me. Okay, one person is saying good for me. What about the remaining? Morning is difficult for me. Next weekend onwards, then weekdays will come. Okay, won't have the class on weekends. We'll have on weekdays only. Okay, then, guys. Thank you for attending today's session. We'll see you all tomorrow. I'm expecting to finish this linked list topic by the end of this week, like the coming week. So hope it gets completed by then. Yeah, thanks and good night. Bye bye.